All right, so in this section, we're going to look at definitions of relative maximum and minimum and as it relates to functions. Um, so I'm going to let you read the formal definition that your textbook has about relative maximum, relative minimum. I'm going to break this definition down. So the relative maximum of a graph is the y value of the highest point in a particular region. Okay. And the relative minimum of a graph, it is the y value of the lowest point in a particular region. So let me explain, or at least show you what it means. So we have a graph here, and it says here, use the graph to find each of the following: the numbers, if any, at which f, your function, has a relative maximum, which are what are these relative maxima? And I'll explain that. The numbers, if any, at which f, your function f, has a relative minimum. What are these relative minima? Okay. So if I wanted to find, not if, but we're looking at the first graph, what is the highest point, not including the infinity, but the highest point where we have an x value, we have a y value of this graph here? We can highlight it. That will be 3, comma 5. Okay. So what this is saying, and I'm going to write it out in words so that you understand. For the relative maximum, we said that the highest point of this graph is 3, comma 5. Okay. It says your function f, what this means, has a relative maximum, or we can say max, of 5. This is your y value when x is equal to 3. That's what this means. That's your highest point of this graph. The relative maximum is 5 when x is 3. So it says here, the number, if any, at which f, your function f, has a relative maximum. What are these relative maxima? It's just maximum, maxima. We have the shortcut, long version, short version of it. So we would say the relative maximum would be 5, okay, because it says look at the y value. But if we want the entire point, we would just write out the ordered pair. So 3, 5. Now it says what would be the minimum. We don't have to necessarily have to have 1 point. It can be 2, 3, 4. Look at your graph. What's the highest point in the graph? What's the lowest point? Our lowest point, we have one here and one here. This is 2, 1, and we have 4, 1. Okay, so what this is saying here is for relative minimum, your function f has a relative minimum of, what's that, 1 when x is equal to 2 and when x is equal to 4. Or we can say this separately. That should be variable n. Okay. When it has a relative minimum, the smallest y value, that's what we're looking for. We have 2, 1 We're looking for the y value, and we have 4, 1. The smallest y value is 1 when we're talking about relative minimum, relative maximum. Okay? Now, the next example. This time you have a screenshot of what you would see if you enter this information into your graphing calculator. This equation, 2x cubed minus 6x squared minus 18x plus 7, this is the graph that you're going to see. But what we haven't talked about is the window, the range. Okay, so let's talk about this. This first box, the bracket, represents your x values, or I should say your x-axis. Meaning your minimum x value is -5 on the x-axis. The maximum is +5. And then this is where this last number is increments. You count by increments of 1. Okay? So we would say, look along the x-axis here. 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. This would be your range, okay, on the x-axis. Now, the second set you see, we're talking about the range on the y-axis. But this time it's counting by increments of 10. So hear me out. This means increments, counting by increments of 10. So here is 0. Then you're saying 10, 20, 30, 40, 50, 60. And then we go from negative 60 to positive 60. So on the y-axis, the min value will be -60. The max will be positive 60, but we're counting by increments of 10. -20, -30, -40, -50, -60. So now it's saying, okay, given this graph, what would be the highest value? What would be the relative minimum? What would be the relative maximum? So we don't know what that is. So what we're going to have to do, we're going to have to figure this out. We're going to have to go in, tell me what is the x value for the where's the highest point that you see here. It's not at 2, but at -1. That's your highest point, okay, at -1. So we know when x is -1. Now let's find the y value. So here's your max. Your max value is at -1, but what would be the relative maximum? We need to find that. So when x is -1, we have our equation that's listed, 2x cubed minus 6x squared minus 18x plus 7. Let's plug that value in. So 2 times -1 cubed minus 6 times -1 squared minus 18 times -1 plus 7. Let's do the exponents. We have 2 times -1 because -1 cubed is -1 minus 6 times 1 minus 18 times -1 plus 7. And then we have -2 minus 6 plus 18 plus 7. Let's calculate that so we can find the highest y value. So -2 minus 6 plus 18 plus 7, that gives us 17. Okay. f of -1 is 17. Okay. Now we want, that's your relative max. Let's find the min. So what's the smallest value that you see? What's your x? At 3. So we're going to substitute 3 in for x into the equation that's given. Okay. So we have 2 times 3 cubed minus 6 times 3 squared minus 18 times 3 plus 7. That's going to be, excuse me, 2 times, what's that, 27 minus 6 times 9 minus 18 times 3 plus 7. I know that's kind of hard to see. Sorry about that. That's 2 times 27. Let's multiply that together. It's 54. And then -6 times 9 gives us 54. And then -18 times 3, that gives us -54 plus 7. And then that would give us -47. Therefore, our relative min at 3 is -47. There we go.